Hi, myself Manish Sharma, currently pursuing BTech from Dayalbagh Educational Institute in Civil Engineering. Recently, I am learning a course that is Structural and Foundation Design and Analysis from Skyfi Labs. Here is an assignment given to me that is Design and Analysis of G plus 23 building. This building is mainly divided into four components of stories, that is story 1 to 8, story 9 to 14, story 15 to 19 and story 20 to 23. The cross sections of beams and columns are as follows. Column cross sections 500 cross 500, 550 cross 550, 600 cross 600. Beam cross sections 500 cross 300, 550 cross 350, 600 cross 400. We have to use M40 grade concrete, HYST 500 as longitudinal reinforcement, mile 250 rebar as shear reinforcement. For slab, we have to design 150 thick slab made up of M40 grade concrete. As a cladding option, we have to select auto drag block cladding. As we talk about loadings, there are mainly three types of loadings in this project, that is dead load, live load, wind load. There is also a cladding load of 0.2 kN per meter. Dead load is uniform for all the stories of the building. Live load is different for different component of stories, that is 5 kN per meter square for story 1 to 8, 4.5 for story 9 to 14, 4 for story 15 to 19 and 2 3.5 for story 20 to 23. So let's go into the software for the steps. So this G plus 23 building I have already analyzed and designed. So I am explaining you the steps involved to design and analyze this G plus 23 building. First we have to define the grid lines along x and y direction. I have chosen 4 grid lines in x and y direction both of spacing 6 meter in each direction. After defining the grid lines, we have to define the number of stories, story height. As the story is different in 4 components, so we have to choose similar stories option for each 4 component. That is story 1 to 8 are similar, story 9 to 14 are similar, story 15 to 19 are similar, and story 20 to 23 are similar respectively. After defining the story, we enter into the software, and here this window is shown to us. First we have to define the material properties. So material properties, I have defined M40 grade concrete first, then HYST 500 steel, then mild 250 steel. After defining the material properties, we have to define section properties. In section properties, we have to define frame sections, beams and columns. So there are 3 cross sections of beam and 3 cross section of common column. But the important part is that for select analyzing this building, we have to assign the section properties of beam and column with the help of auto select beam and auto select column. So we have to define auto select beam and auto select column also in the section properties. After defining the section properties of beam and column, we have to define the section properties of slab. From here, our slab is 150 thick and M40 grade concrete it is made up of. After defining the slab section, we have to draw the claddings of the wall claddings, then assign the cladding load of 0.2 kilonewton per meter. After assigning the cladding load, we have to assign the dead load, lab load and wind load. First, we have to define the load pattern. Live load and dead load are already predefined in the software, but we have to define the wind load manually in this software. So first we have to type the wind here, then select the wind from the drop down menu, then select the IS code from here. For wind load, we have to follow the IS 875 1987 part 3 and then click OK. Then we have to modify lateral load. Here these are the some parameters which we have to define for assigning the wind load. These parameters are wind load, terrain category, structure class, risk coefficient, K1 factor, topography, K3 factor. These parameters we get from the IS 875 part 3. First, wind speed. Wind speed is given on the map here. First, we assume that this building is made in a Bangalore city. So for Bangalore region, the wind speed is 33 meter per second. So we type the value 33. Terrain category is 3, structure class is C, risk coefficient K1 factor is 1 and K3 factor is 1. These all parameters we have given in the IS 875 part 3. Then we click OK, then OK again. After defining the wind load, we have to assign these loads. For assigning, so first we have to assign dead load. Dead load is uniform for all the stories. So we assign frame loads, distributed, then select dead load from drop down menu. Then enter the value of 2 kN per meter here and apply, then OK. After assigning the dead load, we have to assign the live load. Since live load is different for each component of the stories, that is for story 1 to 8 it is different, 9 to 14 it is different, 15 to 19 it is different, and 20 to 23 it is different. So for different component of the stories, similar stories, we have to assign live load differently, like 5 for 1 to 8, 4.5 for 9 to 14, 4 for 15 to 19, and 3.5 for 20 to 23. After assigning the live load, we have to assign the wind load. For assigning the wind load, we go to assign shell load, wind pressure coefficients. Here we have to select wind from the drop down menu. Wind pressure coefficient can be seen from the IS 875 part 3 table number 5. So we go to the table number 5. Yes, this is table number 5. In our building case, our height to width ratio is greater than 1.5 and less than 6, and length to width ratio is 1. So this is the case of our building. In this case, A is the windward side, B, C and D are the leeward side. So we have to, for A, wind coefficient is 0.8, for B it is minus 0.25, for C and D it is 0. Minus 0.8, minus 0.8 respectively. So first take the elevation view, A section, OK. Select all the shells present here and then assign shell load, wind pressure coefficient, then type plus 0.8, then apply, then OK. Similarly, assign the wind load to section B for side A, section 1 and 2, 4 and 3, D and C respectively as given in the IS code. After assigning the all types of load, we have to analyze the building. So set load cases to run. These are all the load cases which are we have defined. We have to run the analysis for all these types of load. So click on run now. The analysis is starting. It takes some time and it also depends on the configuration of our system and the height of building we are using or the stories of building we are preparing. So our building is of G plus 23. So it takes some little more time to analyze the result. So our analysis is running. it shows the progress of our analysis. It's about to complete. Just take few seconds. Yes, our analysis is complete. Here in this window, it shows the deformation shape of the each and every story. So as we move the cursor to these deformation shapes, we get the value of deflections in x, y and z directions and the drift at each point. We can also see other values like shear force, bending moment and stresses. For example, I want to see the shear force diagrams. Then I click shear force, then OK. Then this window displays us the shear force diagram. Similarly, if I select the moment about 3 3, then it also shows the bending moment diagrams in 3 direction. So after analyzing, we have to check the design. So design, concrete frame design. We review revised preferences. We have to select IS 456 2000. Then concrete frame design. We have to start design. So it also takes some time to check the design, that whether our design is correct or not, whether particular types of members, column, beams fails or survive the load given to the building. So it takes some time to analyze because our building is high. Yes, it's done. So on zooming, it shows the reinforcement, detailing reinforcement area and the amount of reinforcement in the top and bottom fiber of beam and column. So we have to check whether our members are pass or fail. To verify all members passed, check yes, all concrete frame passed the design check. Then click OK. So after doing this, we also see the detailing of beam and column. Like if I want to see the detailing of beams, and it takes some time. It is generating the detailing of beam. It is generally generated detailing of beam for all the stories. So we have to select first for which story we want to see the details. For example, I want to see the detailing for story 4. Then click OK. It generated detailing of beam for story number 4. So these are all the types of detailing: repar details, beam details for CB1 type beam, CB2, CB3, CB4, CB5. These are the name of beams. And if I want to see the 3D view, I can also see the 3D view of our story. Yes, this is the beam reinforcement detailing in the 3D view. Then OK. Similarly, you can also see the detailing of columns. So after seeing the type of detailing, you can also see the report of our model. Actually, this software automatically generates a project report. So we can also see the project report from here. It takes some time to load the report. Wait some seconds. Our report is generating. Yes, our report is generated. So we can also zoom from here like 150%. 100% is sufficient. Yes. So this is the report. These are the table of contents, structure data, properties, loads, analysis result. So all these parameters are shown in this report. So this is all about this assignment. So thank you very much.